All right, we're going to finish off our discussion of circles by doing the problems essentially in reverse. Instead of starting with the equation and then ending up with finishing with the center, the radius, and the graph, we're just going to do the problems pretty much in reverse. Meaning, we'll start with some information about a picture. We might give you guys the center, the radius, or something similar, and then ask you guys to work backwards to the equation. So, some sample problems. Can you guys help me find the equation of a circle who has a center at -4, 2, and that would have a radius of 3? All right, so the idea would be that we start with the standard form for the equation of a circle. So x minus h squared plus y minus k squared is equal to r squared. And all we're going to do is we're going to replace h and k with the coordinates for the center. So we're going to replace h with -4 and k with 2. All right, so that then becomes x minus a -4, so x plus 4 squared, y minus 2 squared, and then we're going to replace the value for the radius with 3, which makes it 3 squared, or 9. All right, and so there what we'd have is the standard form for the equation of a circle. Okay, so not very difficult when we're given the center and the radius. But we might be asked a second question. A second question might be, can you find the general form for the equation of a circle? Well, what we do is we start by finding the standard form. That one's easier. Now to find the general form, we just have to FOIL the first binomial, FOIL the second binomial, and then just do one little algebra step at the end. So let's do the FOIL. I'm going to use the shortcut that we've talked about many times. To square a binomial, it's the first term squared. The first term times the second term times 2. So x times 4 times 2, so that's 8x. And then the second term squared. Shortcut again, first term squared. First one times the second one times 2, so that'd be -4y. And then the second term squared. -2 squared is 4. So we FOIL out the two binomials, and then we put it into our form, ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to 0. All right, and what that requires of us is to put the x squared term first. There is no xy term, so we get to skip that one. Then the y squared, then the x to the first, the y to the first, and finally the last algebra step, we need to take all three of the constants, all three of the numbers, and put those fellas together. On the left-hand side, we have 16 plus 14, which is 20. But to get 0 on the right-hand side, we'd need to move that 9 to the other side. So 20 minus 9 is 11. And that would then be the general form for the, for the equation of the circle. Okay, so please just notice what the directions tell you on any problem, whether it asks for standard form or general form. Okay, so let's just try a couple more. How about if I were to tell you instead of the center and the radius, how about if I were to tell you the center and a point that the circle passes through? Now, geometrically, what that would mean is we have a circle that has a center at 7, -1, and then it would also go through the point 3, 5, so it passed through this point, so the circle would go looping around like that. Okay, so can we get to the equation? Again, we'll start with the standard form. So x minus h quantity squared plus y minus k quantity squared is equal to r squared. And again, we need three values, h, k, and r, just as we had on the previous problem. Well, h and k are easy because I tell you where the center is. So for h, we put in 7. For k, we put in -1. And please remember opposite signs, right, guys? Opposite signs. So when we put 7 in, it actually then reads as x minus 7. When I put in -1, change the opposite sign, so it actually reads as y plus 1. So just a reminder there. Now the other value we need is the r. All right, so of course the r, if you go back to the picture, r would be the distance from the center to that point. That would be the radius. And of course you guys could find that using distance formula. You could just find the distance between the 2 points. But please notice what would happen if we take the coordinates for this point and just replace x and y with them. Now keep in mind, right now, we're 2/3 of the way done. We have the h, we have the k, all we're missing is the r. So just keep that in mind, we're 2/3 of the way done. But please notice what happens if I replace x with 3. So I replace this x with 3 and this y with 5. All right, what's the only variable left now? R. And that was the other thing we were trying to find. So remember, we're trying to get our answer to be x minus 7 squared plus y plus 1 squared is equal to r squared. That's what we're shooting for our standard form answer. So that means we can just solve for r squared. 3 minus 7 is negative 4. In fact, I'll just write that out. 5 plus 1 is 6. Negative 4 squared is 16. 6 squared is 36. 16 plus 36 is 52. Now, if you wanted me to, I could take the square root of both sides. And so r would be the square root of 52, and you could try to reduce that or write it as a decimal. But the number that goes in our equation isn't r, it's r squared, and that's what we have there at that step. So I could replace r squared with 52. And that then would be the standard form for the equation of the circle. Okay? So we have the h, we have the k, and we have the r squared value. All right? And then I tried to just make one a little bit tougher on everybody. What I gave you on this third example is the endpoints of the diameter, and my directions would be to find the equation of the straight line. So again, equation of the straight line, good gravy. Equation of the circle is what I meant to say. All right, and so our starting point would be x minus h squared plus y minus k squared is equal to r squared. We need three things, h, k, r. We don't have any of them to start with, so if it helps, we could draw a little bit of a picture out here just to help out. One of the points of the diameter is left 2, up 3. And then the other one is 8 to the right and 5 down. So the diameter would run from -2, 3 to 8, -5. Well, if that's a diameter, how does that help us at all? Well, what we'd have to remember is that the center of the circle would be halfway between, because from the center to one point would be a radius, and from the center to the other point would be a radius as well. So the center is going to be halfway in between. And in the past, we had a formula for the midpoint of a line segment. I'll remind you of it. It was x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So the midpoint for that line, which is going to be the same as the center of the circle, is x plus x, so -2 plus 8 divided by 2, and then y plus y, 3 plus -5 divided by 2. And when you guys do that math, -2 plus 8 is 6, and 6 divided by 2 is 3. 3 plus -5 is -2, and -2 divided by 2 is -1. We find that the center of the circle then is located at 3, -1. Therefore, we'll replace h with 3 and k with -1. So here we go. We've got h being 3. There we go. And we have k being a -1. All right, and my y looks ugly there, so I'll try to fix that up for everybody. Make that look a little nicer. There we go. And then the last value we're searching for then is the r squared. All right, we're looking for r squared. And again, now that we know where the center is, we know the center is located at 3, -1. We could use distance formula to get from the center out to a point, or again, we could just pick one of the points and put in those values for x and y. Okay, to find the value for r squared. Again, the idea is at this point right here, we're 2/3 of the way done. So we're 2/3 of the way done right here. So if we just want to pick up one of the points, let's just for the heck of it use the 8, -5. We could replace x with 8 and y with -5. And that allows you to solve for r squared because that's the only variable left. So 8 minus 3 is 5, and 5 squared is 25. Negative 5 plus 1 is negative 4, and negative 4 squared is 16. 25 plus 16 is 41. And therefore now I can be completely done by replacing r squared with 41. And that would be the standard form equation of the circle. And of course, if you needed it in general form, you could just FOIL, and get 0 on one side. Okay, but I'll leave that to you guys just to do for a little bit of fun. Okay, so that's one problem that we could do. Another problem that we're going to be asked to do, and that's helpful, is to be able to find the x and y intercepts of a circle. Okay, so as an example, if I give you guys the equation x minus 3 squared plus y plus 2 squared equals 21, can you tell me about can you find, I should say, the x and the y intercepts? Now, all I need you to remember is that when a curve passes through the x-axis, I'm just making something up. I'm not saying it represents this problem, but wherever a curve goes through the x-axis, what's got to be true about those ordered pairs? When something goes through the x-axis, what must be true? When it goes through the x-axis, the y values have to be 0 because we're not going up, we're not going down, we're staying on the x-axis. So our y value is 0. So to calculate x-intercepts, which I'm just going to abbreviate, what we do is we replace y with 0. So if I leave the x alone, but I replace y with 0, notice it's not it's not y plus 2, it's 0 plus 2. Now what's the only variable left? X. So of course I can then solve that equation for x. All right, in a whole variety of ways I could do it, but I'm going to choose to do it this way. 0 plus 2 is 2, and 2 squared is 4. Then move the plus 4 to the other side by subtraction. 21 minus 4 is 17. Then get rid of a power of 2 by taking the square root of both sides. So on this side, the square root and the square cancel. And then whenever we take the square root of a number, plus or minus, and the square root of 17 doesn't turn out very nice, so I'll just leave it as that. And then move negative 3 to the other side by addition. So then the x values would be positive 3, because we moved it to the other side, plus or minus the square root of 17. And just on this first one, I'm going to approximate those as decimals for everybody, just so you can get a feel for it. So 3 plus the square root of 17, excuse me, would be about 7.1, and 3 minus the square root of 17 would be about negative 1.1. So I'm fine with the exact answers, leaving them in radical form, but if anybody wants to approximate, that's fine as well. Okay? Then secondly, I'm going to switch colors just so you can see the difference between the two. Now I'm also going to ask you to find the y-intercepts. And when a curve goes through the y-axis, no matter where it is, high or low, what's got to be true about those ordered pairs? When something goes through the y-axis, we haven't moved left or right. Therefore, the x value is equal to 0. So to find y-intercepts, what we do is we replace the x with 0. And by replacing x with 0, now the only variable we're left with is the y, which means we can solve for it. 0 minus 3 is negative 3. Negative 3 squared is 9. I think you'll see the algebra is really familiar. We'll move the 9 to the other side by subtraction. Get rid of the power of 2 by taking the square root of both sides. And then move the plus 2 to the other side by subtraction. So the exact values would be negative 2 plus or minus the 2 square roots of 3. And again, just on this first one, I'm going to approximate those for you so you have both of them in front of you there. So negative 2 plus 2 square roots of 3 is approximately 1.5. And then negative 2 minus 2 square roots of 3 is approximately negative 5.5. 5.5. Okay? So we can find x and y intercepts pretty easy. I do need to run through a second example though, just because something special happens occasionally, and I just need to make sure we talk that through. So again, I'm going to find x-intercepts, and I'm going to find y-intercepts. Okay, when we have a curve that passes through the x-axis, that means the y's are going to be equal to 0. So what we do is replace the y with 0 in our equation. And when we find y-intercepts, we replace x with 0. And then we're able to solve for y. Okay, so let me do the solving for you guys. For the y-intercept, 0 plus 2 is 2, and 2 squared is 4. Move plus 4 to the other side by subtraction. 12 minus 4 is 8. Get rid of the power of 2 by taking the square root of both sides. So y minus 6 would be equal to plus or minus, and when I reduce the square root of 8, I get 2 square roots of 2. And then move negative 6 to the other side by addition. And this time I'm not going to approximate, I'm just going to leave them as exact values. So it'd be 6 plus or minus 2 square roots of 2. So we have the two locations where the circle would cross the y-axis. Now let's go back and solve to find the x-intercepts. Again, similar solving here. 0 minus 6 is negative 6. Negative 6 squared is 36. Move 36 to the other side by subtraction. 12 minus 36 is negative 24. Get rid of a power of 2 by taking the square root of both sides. So x plus 2 is equal to plus or minus, and I'll do the simplifying for you. The 24 is not the important part, but what happens with the square root of a negative? The square root of a negative has to get pulled out as I. And even if you don't see it yet, when we move the plus 2 to the other side by subtraction, what kind of numbers do we get then for our x-intercepts? Complex. The I tells us that we have complex solutions. Now, what does that mean in terms of the intercepts then? Well, if these turn out to be complex, that means that there's going to be no locations where the circle passes through the x-axis. And of course, that shouldn't be a big surprise if I slide off to the side just for a second. We should be able to draw a circle that hits both axes twice. No sweat. We should be able to draw a circle that just hits the x-axis twice and doesn't hit the y. We should also be able to draw a circle that hits the y-axis twice without hitting the x. So we have all kinds of ways in which we can draw. In fact, I should put one more on there while I'm thinking of it. We can also draw a circle, of course, that doesn't hit any of the axes. All right? But when we want to try to find them, the process isn't too tough. To find x-intercepts, replace y with 0. To find y-intercepts, replace x with 0. Okay? And then just to finish off, if you guys needed some help, I didn't do this on the first video because there's so much other work to do. I thought I'd save it for this one. But if anyone wants to graph a circle using their calculator, then what I'd need you to, what I'd need you to be able to do is get it in a form that can be entered into your calculator. Of course, on your calculator window, let me see if I can do this. Let me see if I could get this in close enough. Of course, on your calculator window, what we've got going on is a menu that just says y equals. So how are we supposed to input something that has a y squared in it? How are we supposed to input something with a y squared? And the answer is we'll have to solve your equation for y so that we can enter it into your equation. So I'm going to need to move this positive term to the other side by subtraction. So this would then be y plus 4 squared is equal to 25 minus, now in parentheses, x minus 2 squared. Then we'll have to get rid of a power of 2 by taking the square root of both sides. But remember, whenever we take a square root, plus or minus, so we'd have plus or minus the square root of 25 minus x minus 2 squared. And then I'd have to move this plus 4 to the other side by subtraction. So I'll move that plus 4 to the other side by subtraction. And the equations are terrible looking. Kind of a mess. But the equations that we'd have to then put in are y equals negative 3 plus or minus the square root of 25 minus x minus 2 squared. and I think I may have forgot to say the square root there. All right, but we'd have to enter that whole thing. Now we can't do both of these fellows at the same time. We can't do both of those folks at the same time. So what we'd have to do is enter two of these. We'd have to tell our calculator for y1 to input -4 plus the square root of 25 minus x minus 2 squared. And then for y2, we'd have to tell our calculator to graph -4 minus the square root of 25 minus x minus 2 squared. So we'd have to enter both of those into our calculators and then hit the graph button. And let me see how my calculator does. I'll just get myself going here. -4 plus a square root of 25 minus x minus 2 squared. Let's see, I've just got to make sure I have the right parentheses. Yep, I do there. And then -4 minus the square root of 25 minus x minus 2 squared. And I think I have that okay. So let's see, I've entered them. I'll turn on my camera here so that hopefully you guys can see it a little bit. So there's the equations. And then when I hit the graph button, let's see if I've done it correctly or not. Okay. Now, just a couple little things. First of all, the calculator doesn't finish off the circles very well. Like I've told you guys before, calculators don't like to graph things really vertical. So the vertical parts, the left and the right side of the circle, aren't drawn very well. And secondly, it doesn't look like it's a circle. It looks more stretched out. But remember, because our calculator screen is wider than it is tall, we get kind of a discrepancy. We get kind of a, not discrepancy, a distortion. But remember, we can correct that using the zoom button. So we could hit zoom, and then we pick option number 5 that says Z square. So if I choose that option, it then squares up the screen for me, and the circle looks a bit better. It's still not perfect because it doesn't like to complete the vertical portions of the circle, but it looks a little better. Okay? So hopefully if anyone wants to try any of those on your calculator now, you can kind of figure that out. Try a couple and see how you like it. It's still a little bit of work though, right guys? You still have to do this work to get it into the correct form. Okay? So that should be the end of the circle part of section 1. So you guys should now be able to do any of the 10-pack problems, 18, 20, 24, 26, and 32, plus any of the other problems dealing with circles that you want to do just for fun. Okay, the next video we'll start talking about parabolas, and that's a continuation into section 1. Okay, so take a little bit of a break, try some of the problems dealing with circles, and then we'll see you on the next video. Have a good day.